Yeah, you need to execute the code again. Maybe you have executed this today. Did you execute or yesterday?
Today only, sir. Today only.
Okay, execute it again. See, X try X is the capital letter there. I already told you Python is the case sensitive. You need to give the correct variable name, then only it will understand. So what is this extrain dot head?
Sir, this is the input data, sir.
Yeah, can you check X test dot head? Okay,
Yes,
so
sir.
whatever the X test you do have, and this prediction is there na array of 103 comma 80. Those
sir.
are the Y values. Those are the predictions from the model.
Okay, sir.
This 103 is the prediction for the first row, 103.80.
Okay, sir.
Can you check Y test dot head also? After this, yes. No, why are you removing? You should not remove. X test dot head. Why small letter man? See, that's why variable you should be keen in checking each and everything. You should be careful. See, your actual value is 92. Okay, na?
Yes, sir.
Our model predicted that as 103. You got it?
Yes, sir. Yes, sir.
103.80 our model predicted. Second row, our actual value is 119. Our model predicted that as 131. Same scenario, fourth row is 97. Our model predicted as 93. Okay, na?
Thank you, sir.
Clear?
Yes, sir.
Yeah. So apart from Prem, anyone? Jasmita, you can showcase your error.
Yes, sir.
See why I am giving this much practice. Whatever the code I have given you, whatever the code you are executing now, the same code you can replicate during your real-time projects also. If you are not able to practice now, then again maybe if you get opportunity in the companies, you will become dumb. So if you are practicing now, it will be easy for you to implement the code and to write the code in your real-time projects also. With X train, comma Y train.
Sir, I'm
Okay.
getting some data type error here.
Scroll below. Class could not be prompted. Numpy data this means has no. Scroll above. Scroll above. Wait. X comma Y. Test size 0.10. X train, X test, Y train, Y test. Yeah. Can you check X train info, Y train info?
Yes, sir.
If you are getting this type of no, after that only, after splitting. No, after splitting only. Yeah, wherever you are getting that error, there only you can check. It's just a matter of adding cells and checking your output. Just go above, little bit above. After 34th input, this is the 34th input, add 2 or 3 cells. Put your cursor at 34, add cells. Check X train info. We can use shift enter also, Jasmita.
Okay, sir.
No need to go to that command. X train is not defined. Can you execute it again? X train above code. X train X test. When did you execute this code? Yesterday or today?
Today, sir. Today morning.
Yeah. Can you execute 33rd row, 33rd input?
Once again, sir.
Yeah. Name X is not defined. You need to execute from the start again. Scroll above. See, if you shut down your laptop, again you need to re-execute the code. If you put your laptop in the sleeping mode, there is no need to execute. Maybe you would have restarted your kernel, something else would have happened. If it is not defining variables means these variables are not in the Python memory.
Okay,
You
sir.
need to execute again. Scroll above, you can execute the code from the shorting.
Okay, then I have to do it from starting, which I define.
Yeah.
Okay, sir. So
So
then later I won't get error, right, sir? Once I
try
execute
it
from.
now. It's a
Okay.
matter of seconds only. It won't take much time. It is
Okay,
just
sir.
small data set only. Na? So and
Okay.
one more thing, what about the sales project, whatever we have discussed? So is it
Yes.
working fine?
Yeah. Yes, sir. It's okay.
Okay. Just execute line by line code, cell by cell.
Uh,
See, because why you are getting this error means machine learning models or deep learning models, it can't take string values, object values, and date time values. Do you remember that?
uh,
You have date column in your data set. That is date time 64NS. Can you see the first row in the
yes, sir.
xtrain.info?
Yes, sir.
You need to remove that column from your model building. You need to drop that column.
Okay, sir.
Okay, na? We do have column, right? Dot drop
Yes, sir.
x equal to base data dot drop. There we can add that date also apart from purchase.
Yes, sir. That's
Just add it in the list of elements. Or else you can do it separate line of code also. In the place of purchase, you can replace it with the date. What is the variable name you need to use at the right side? Base data dot drop or x dot drop, x train dot drop.
extrain dot drop.
Either you can do it on the x train level or you can do it on the base data level also. It's up to you yourself.
Okay, sir.
If you are doing it on the x train, you need to do it on the x test also.
Okay, sir.
Okay. Whenever you are passing 10 columns, just do it now only. You will get the code execution. Why again you need to wait for some other time?
Okay, sir.
Just wait.
Is this correct, sir?
Yashmita, you need to change the variable left side also. X equals to you need to change this too.
And this also I need to change, so
Yeah.
it should be x_train.
Yes.
Is this correct, sir?
Yes. Now execute, your code will work. Scroll down. See, you need to drop it in the exit test also. That is what I told you. Can you see the error? No, no. You should understand that error before fixing
Yes.
that. What it is mentioning, the feature names should match those that were passed during fit. Feature names unseen at fit time. Date. You got it. You're able to understand the error, right?
Yeah, yes, sir.
At the training, we are able to remove the date, but now we are giving the date in the testing period. That's why it is giving the error.
Okay, I should delete drop test in the test also.
Exactly, exactly. Add another line of cell after 32. After 32, add it. We should make a habit of reading the errors, Python code errors. Whenever we are writing the code, we should be getting those errors, right? We should be in the situation to understand those errors also. If you are getting more errors whenever you are executing the project, that means you are trying something. If you are not getting errors, means you are simply executing the code, you are not trying that much. That is same only. You need to execute that. Execute that before that. If you simply write the Python code, what does it mean? You need to execute. It should save in the Python memory. Na?
Yes, sir.
Now execute it.
Yeah, it's
Now it's working, right?
yes, sir.
So these are the prediction values. So we need to compare our y test and this prediction values both. Can you check y test in the below cell? Check y test here. So you need to see. So how the difference we are predicting, whether model is predicting correctly or not. Can you print the y test below? Yeah, in that cell, print y test.
Yes.
Small y. Normally X we will be treating capital X and the target feature we will be treating with small y.
Yes, sir.
It's up to you. There is no specific rule, but normally the people used to follow like this. So that's why it's using in that format only. Execute it. This is the output, you got it. Okay, now 105 is our actual value, and our model predicted that as
151.
154. Exactly. So 129 is our actual value. And what is this left values? 151, 126, 109, 12, 168.
I
What
think
it will be called?
column number.
Those are indexes. Okay, now those
Yeah.
are index numbers. That is row numbers. In train test split, it's shuffling. It will split. It won't split in the order. It will do shuffling.
Yes.
Okay.
Yes.
So clear.
Yes.
So anyone? If anyone having any doubts, you can share your screen and you can ask. Okay, let's move on to the classification project. See, nowadays, now it's completely project will come, project theory will come. Within the project, if you are missing any miscellaneous concepts, it will cover in that project. That is how the process will be. Once this classification project is completed, next I will be discussing on the NLP project, that is natural language processing. So can anyone tell me what is classification? Why everyone silent?
Predicting the value.
Yeah, predicting the
Target the values for future class levels.
in the regression, we will be predicting the continuous values like this, like stock values, sales values, something continuous values. In the large, in the classification, we will be predicting the class labels like 0, 1, 2, 3, 4, 5, something else like that. So the linear regression formula is y equal beta naught beta 1 x1 plus beta 2 x2 plus beta 3 x3 like that. And the same formula will be followed for the logistic regression also. That is also y equal beta naught plus beta 1 x1 plus beta 2 x2. The only difference is whatever the output we are getting from this y, this will be passed over to the sigmoid function. So for this sigmoid function, we will be having this formula called 1 by 1 divided by 1 plus e power of minus y. So this y is nothing but beta naught beta x1 plus beta 2 x2 like this. So this formula also we have already seen, and we have already seen how this sigmoid function also works. This is the major difference between linear regression and logistic regression. And if probability value, normally whenever we are passing to this sigmoid function, we will be getting these probability values from 0 to 1. If probability value less than 0.5, then we will be predicting that point as label 0. If probability value is greater than or equal to 0.5, then we will be predicting the new incoming data as the label 1. So if you want to change, by default, logistic regression will follow this threshold. If the probability value is less than 0.5, it will predict as label 0. If probability value greater than or equal to 0.5, it will predict that as label 1. So if you want to change this threshold value, we can change it. But by default, logistic regression will follow this probability value. We can change this probability value also. We can change it to 0.8, 0.9. So normally in the banking domain, they need more accurate results. So that's why they will be following the probability value of 0.8, 0.9, something like that. It's up to you. Okay. So this is the classification thing. Next, we will be discussing NLP. During our next session, we'll discuss that. And we have already discussed what are the algorithms are covered in this classification also. We have already discussed binary classification means if we have two outcomes, that is male or female, that will come under the binary classification. If you have more than two classes, that is male, female, and transgender, for example. So three classes here it came. So we can call it as multi-class classification. And next, another important thing is multi-label classification. So multi-label classification means normally as of now, we have seen only one output variable, that is x1, x1, x2, comma x3, comma x4, comma y only you have seen. That is, in the y, you will be getting values like 0, 1, 0. These are all the rows. This is first row. This is first row. This is second row. This is third row. Like this. This is binary classification. If you are getting more than 2, that is 0, 1, 2 in your target variable. So 0, 1, in the fourth row, you will be getting another class label like 0, 0, 1, 0, 2. See, here it will be called as multi-class classification. This is multi-class classification. Let us see what is multi-label classification. Here, predicting 2 target variables. See, in this example, even though it is binary classification, only 1 target variable. Here also 1 target variable. In the multi-label, we will be having 2 target variables. That is more than 1 target variable. That is x1, x2, x3, x4, y1, y2. So here 0, 2, 3, 4, 5. So in the y1, you will be getting 1 target variable, like for example, in the y1, we do have Cancer is there or not. So normally we will be representing Cancer is there. We will be representing as 0. So Cancer is not there. We will be representing as 1. So here y1 we will be representing with 0, 1. So if you are predicting 0 means Cancer is there. If you are predicting 1 means Cancer is not there. For example, if Cancer is there, again if Cancer is there, again we will be getting multiple cancers. So first type is bone cancer. Second one is blood cancer. Third one is some other, you can tell, lung cancer, let us suppose. So here again subcategories here. So again bone cancer, blood cancer. So here bone cancer I can represent it with 0, and blood cancer I can represent it with 1. Lung cancer I can represent it with 2. So wherever, so no cancer also we can represent another thing. So let us give it as 3 number here. So what is the y1 here? Y1 we are predicting as cancer is there. So sub-cancer is blood cancer, let us suppose. In the below example, no cancer is there. So 1 means cancer is not there. That means here label 3 will come. So here 0. In this example, the person got bone cancer. In this example, the person got lung cancer. So in this example, there is no cancer. Sorry, 1 means no cancer. That is no cancer label is 3. Like this, we will be predicting two class labels. That is two variables. Sorry, not two class labels. Two target variables will be there in the multi-label classification. See, multi-class classification is different. Binary classification is different. Multi-label classification is different. So here we will be having two target variables. In about two examples, we do have only one target variable. Here we do have two target variables. We can predict y1 and y2 both. Clear, everyone? And as same as algorithms like logistic regression is one of the classification algorithm, and naive-Bayes stochastic gradient descent. So k-nearest neighbors is one of the classification algorithm, and support vector machine is one of the classification algorithm. And apart from that, Bayesian tree classifier we can use, and random forest classifier we can use. Just I have given explanation for all these things. We have already discussed these things clearly. This is the linear regression, and once if we converted predicted y, we are using in the range of 0 and 1. So this is the regression line, and this regression line will be converted into this logistic line whenever we are using that sigmoid function. You should remember the formula for that sigmoid function. See, sigmoid function formula is 1 by 1 plus e power minus z. Z is nothing but y. Some persons will write it as z, some persons will write it as y. The cost function we have discussed, right? So whenever we are implementing regression, we have used mean absolute error as our cost function to update the coefficients. Same here. Here also it will follow the cost function. So here cost function is nothing but log loss. This will be called as log loss. This will be called as log loss. So this cost function we will be using, and we will be improving our model accuracy, and we will be getting the good accuracy there. So the gradient descent we have already discussed as part of our linear regression. So to get the best coefficients from one iteration to another iteration, we will be using this gradient descent. See, the main goal of gradient descent is to minimize the cost value. That is minimum of jth thing. Now to minimize our cost function, we need to run the gradient descent function on each parameter. So logistic regression is designed for classification purpose and is most useful for understanding the influence of several independent variables on single outcome variable. So that is what advantage is. It works only when the predicted variable is binary. So if our predicted variable is binary, then only logistic regression will work. If the predicted variable is continuous value, this won't work. Assumes all predicteds are independent of each other, and assumes data is free of missing values. So we should not have any missing values in our data set. Okay, so here simple project what we have taken. We have taken fruit data. We are just providing that labels also. So fruit name apple is denoted with label 1, and mandarin is denoted with label 2, and fruit subtype. Fruit subtype is, I told you, right, multi-label classification. For that, you can use this fruit subtype, Granny Smith, mandarin, something else like that. And this is the dimensions of that fruit. Some apples may be having 192 mass. Some apples may be having 180 mass. And the width, some apples may be having 8.4, 80, 7.4, 7 height, 7.3, and the color score. So they have given some color scoring for each and every fruit. Maybe the apple is having a little bit dull color, and the mandarin is having highest color like 0.8, 0.7, like something like that. What we have taken? Input features. These are all the features I have taken. I don't want to take this fruit name. Why? Because I already fruit label is available for me. And I don't want to take this fruit subtype also. That's why I'm not considering. I'm just considering mass, width, height, and color score. I'm just considering 1, 2, 3, 4. 1, 2, 3, 4 input features I have considered. And for Y, I have considered fruit label. For Y, I have considered this fruit label. So now my X data is ready. My Y data is ready. If you see, my data is not in specific range. These values are in hundreds, but these values are in tens only, 8s, 6, 7. The scales are different completely. So what I'm using? I'm using min-max scalar. I'm using, we have already discussed concepts called normalization and standardization. To convert all these ranges data into one specific range, we can use this min-max scalar. What I'm doing, I'm converting my data into the scalar format. That is, each and everything will convert into same format. After applying this scalar, what I'm suggesting each and everyone, just see the data. Just see X and scaled X data, how the values got converted. So after this, what you can do, you can check X dot head. Each and every, whenever you're seeing, you need to check. Here I didn't execute the code. That's why it is showing the error. What? Like this. 4, 1, 5, 6, 8. So this is in the text format. Normally this data, I just read it in the format of table. If it is the CSV, we can read it in the CSV. Now, X dot header. This is my X data before min-max scalar is nothing but normalization. And standardization, we will be using standard scalar. The variable called standard scalar. See, min-max scalar is not defined. What I need to do, I need to import that library name. Somewhere above, I would have imported. See, it's already imported. What we can do, or else you can execute this entire libraries. It will execute. So now, once if I executed this, I need to check how my data got converted into scaling format. See, now I converted this into the NumPy array format. Anyway, we can provide the direct data frame to the model or NumPy array to the model. Anything is fine. Before, you do have data like this. You do have these four. Before normalization. These are the four values. So next, after normalization, your values converted into this format. See, 192 converted into 0.40, and this 8.4 converted into this 0.68, and this 7.3 converted into this 0.50, and this 0.55 converted into this 0. Okay, so now what I'm suggesting you try with standard scalar also. You try with standard scalar. You try with standard scalar. What you need to do, we have already did it in our previous project, I think so. Standard scalar. You just need to use that. You just need to use the previous code snippets. It's already available. Just compare normalization and standardization. Then only you will get the full clarity. So standard. So maybe this name could be wrong or standard scalar. This name could be wrong. You need to use the correct name. If you use the correct name, you will get this library imported. So next, what I'm doing, as same as I'm splitting my data set into training and testing, 70% and 30%. As usual, my training data is 41 rows with 4 columns, and my test data is, so here simply what I use 30%, simply use 10%. So 53 rows is my training data and 6 rows is my testing data. As it is, if you are providing 4 columns in your training data, you need to provide the same 4 columns in your test data. So 53 y that is target column and 6 target column in test data. So let us implement. So these are all the y print. This is my y print. I need to test y test. See, y test is Same. Here it is giving wrong predictions. 1, 2, 4, 6. So one label is 1, but my model predicted, sorry, here label is 1. These are the actual values. But our model predicted this as 1. So here label is 1, but our model predicted this as 3. Here label is 4, but our model predicted this as 3. Here this one only correct. This 3, my model is able to predict it as 3. And this 1 also, my model is able to predict it as 1. This 4 also, my model is able to predict it as 4. So how many? So 3 labels I was able to predict wrongly. These 3 labels I was able to predict correctly, and first 3 labels I was able to predict wrongly. So these are the wrong predictions for me. So next what I'm doing, so to measure the accuracy of this classification algorithms, we do have one. See, accuracy of logistic regression classifier on training set is 81%. Accuracy of logistic regression classifier on test data is 50%. That means only 50% of the data I was able to predict correctly. Out of 6 rows, only 3 rows I was able to predict correctly. Remaining 3 I was able to predict wrongly. That's why my accuracy is 50%. So here tell me, my training accuracy is 80%. My test accuracy is 50%. What is the issue here? Is it overfitting or underfitting?
Sir.
Here it is having training accuracy as 80%, testing accuracy as 50%. Here my issue is overfitting or underfitting.
Underfitting.
See, underfitting means you won't get better accuracy on training also. You will get training accuracy also as 50, 40, 30 like that. At least you are getting training accuracy as 80%, right? That is good. But your test accuracy is 50%. This is overfitting scenario. Okay, na? So here training accuracy is good. My training accuracy is good, but my testing accuracy is very bad. This will be called as overfitting. If my training accuracy is bad and test accuracy is also bad, that is, if my training accuracy is around 40%, my test accuracy is around 20%, that will be called as underfitting. There is no accuracy at all, but 80% in training, that is good. At least my model is able to learn patterns. My model is able to train. It is able to understand the patterns. But when it comes to the test data, that is, whenever new patterns are coming into picture, my model is not able to perform. The reason for this is there is no sufficient data available for me. I do have very less data available. See, 53 rows is very less. In the real time, you will be getting millions rows of data to train the ML models. Just for this is a dummy project, just for our explanation purpose, we have taken this. But in the real time, you will get millions of rows of data. Okay. So this is how we need to feed to the algorithm, and let us discuss this precision, recall, F1 score, all those things. So in the regression, we do have performance metrics like mean absolute error, mean square error, root mean square error. In the same way, for classification also, we do have performance metrics called precision, recall, and F1 score. So these are all the things we need to check to tell whether your model is performing fine or not. So let's go to the performance metrics formula. So everywhere it's mathematical formula. See, normally whatever the matrix we are getting here, right? This matrix, we will be calling it as confusion matrix. This is confusion matrix. If you have two class labels, 0 and 1, you will be getting 2 by 2 matrix. If you are getting this 3 by 3 matrix like this is 3 and this is 3 and this is 3. And that means 3 rows and 3 columns. Let us check how many class labels are there in our data set. This is multi-class classification problem statement. To understand this precision, recall, and F1 score, you should start from the binary class classification. Let us see the confusion matrix for binary classification. See. This confusion matrix means you have 3 class labels here. We do have our flowers, right? Setosa, what it is, iris flower, Setosa, versicolor, and virginica. So whatever the diagonal elements are there, these are all the correct predictions. Whatever the undiagonal elements are there, these are the wrong predictions. So here 0, that means no wrong predictions. Here also 0, no wrong predictions. Here also 0, no wrong predictions. But here 0.38, some wrong predictions are there. Here also no wrong predictions. If you see from the 2 by 2 matrix perspective, let us see. Yes. This is positive means, for example, let us suppose cancer is there, and negative means cancer is not there. Let us suppose positive as cancer is not there, and negative is cancer is there. Normally, we will be treating if cancer is there, that is as the negative scenario, right? Let us consider from that perspective. These are all the actual values. On the top side, it is actual values, and here it is predicted values. If my cancer is not there, if my model is predicting that as cancer is not there, that will be called as true positives. Listen it carefully. If I do have, if the person is not having cancer, same time my model also predicted as not having cancer, that will be called as true positive. Same scenario, if the person is not having cancer, but my model predicted that as cancer, that will be called as false negative. Same scenario, false positive. That means here the person is having cancer, but my model predicted as not having cancer. That is false positive. If the cancer, I'm having cancer, and my model also predicted as having cancer. That is, if I am having cancer, if my model predicted as having cancer, that will be called as true negative. If I am not having cancer, if my model is also predicting as no cancer, that will be called as true positive. Let us summarize. Let us summarize the text. Yes. So normally we will be getting 4 terminologies here: true positives, true negative, false positives, and true negatives, and false negatives. So true positives is nothing but if this is just from example explanation only. If the person is having cancer and my ML model predicted as having cancer. That is, having cancer means 0. Let us suppose here my class label is 0 and my model predicted also class label 0. This is true positive. Same scenario. If the person is having cancer and my model predicted as not having cancer. Let us see from this perspective. Here it is having cancer, but not but it's predicted as label 0, label 1. That is wrong. That is label 1. So this will be called as false negative. Okay, if the person is having cancer and my model predicted is not having cancer, but my model predicted as negative, right? Having cancer and having cancer, 0, 0. And if the person is having cancer, 0, true positive, that means positive positive is true positive, positive negative is false negative. That is 1, 0. See, 1, 1 is true positive, 1, 0 is false negative, 0, 1 is false positive, and 0, 0 is true negative. So let us see 0, 0.
So that means
First,
for true
wait,
positive,
wait.
1, 1.
Yeah, right. True positive. Let us suppose he is having cancer. We thought of considering as negative. Right? Let us consider as 1. He is having cancer. He is having normally negative scenarios. We will be considering as negative things. Suppose he is not having. It is positive thing. Not having cancer means positive thing, right? If the person is not having cancer, then it has taken here. Positive is 1. And my model predicted as not having cancer. Yes, 1, 1. This is true positive. So not having is positive, and also same as not having is also positive. So both 1, 1 my model predicted. So next thing, let us say, what if actual value is 1, but my model predicted as is not having cancer. But my model predicted as having cancer. That is 0. So this will be from the image perspective, false negative. That is 1, 0. Yes. This is actual 1, predicted 1. Same below example. Actual 1, predicted 0. So let's move on to the true negative. If the person is having cancer, that is 0, and my ML model predicted as having cancer. That is 1. So here it is. Sorry, as having cancer means 0. So this is 0, 0 is nothing but true negative. Same scenario, false negative also. If the person is having cancer and my model predicted it as not having cancer. Not having cancer means 1. This will be 0. My actual value is 0, but my model predicted as 1. This is the overall architecture of confusion matrix. So this one we will be calling as actual. And this one we will be calling as predicted. So this entire thing we will be representing in the format of matrix. In the format of matrix we will be representing. That's why it is called as confusion matrix. By using this confusion matrix, we will be telling our model is performing well. Let us see how the we can say. So here it is 100. Here it is 5. Below 2, 300. Now tell me what are correct predictions and what are wrong predictions from this matrix. This is my confusion matrix which I got it. Now tell me what are correct predictions and what are wrong predictions.
So 100 is the correct prediction.
Yes, 100 is the correct predictions. And next, this diagonal element.
Yes,
Correct.
300.
So this 300 also correct predictions. So this positive, I was able to predict positive. This negative, I was able to predict negative. And this 5 and 2 are there, na? These are wrong predictions. These are the wrong predictions. So our aim is like, as a data scientist, our aim should be to make wrong predictions as 0 as much as possible, to make them into 0. If I make them into 0, what will happen? Let us suppose if I want to predict, if I want to make this into 0, so this will be converted into 105 and 0 and 0 and 302. This is how the matrix will come. So this means we are getting 100% accuracy. But in the real time, it won't happen. If you are getting predictions like this also, that is also good. Why? Because the error rate is very less. The wrong predictions are very less. It is not possible to achieve 100% accuracy in the real time. Clear? This is from the perspective of binary classification. What if you have 4 classes? That is multi-class classification. Same, you will get 4 classes. So, for example, 100, next to 0, comma 20, comma 0. This is label 0. So next, 1, 2, 200, 0, 0. So next, 2, 6, 567. Example, this is label 0. Below it is label 1. Below it is label 2. Below it is label 3. By seeing this confusion matrix, what we can say, these 100 are correct predictions and remaining these 3 are wrong predictions. That is, if you are getting 0 means label 1, that is fine, no wrong predictions. Here some wrong predictions are there. That means this diagonal element should perfectly come, and whatever the elements after diagonal, it should be 0. If you are getting 0 means your model is working fine. That is how you need to work on this confusion matrix. Clear everyone regarding confusion matrix? We just practice, you will get more clarity. So out of this confusion matrix only, we will be calculating precision, recall, and F1 score. Nothing more than that. So whatever the formulas we will be calculating with precision, recall, and F1 score, all those things we will be calculating from this confusion matrix itself. So normally, if we are trying to calculate true positive rate percent, we will be using the formula called true positive rate. That is this is the formula for accuracy. Our in our model we have used this accuracy, right? This is the formula: true positive plus true negative divided by all of them. True positive plus true negative, false positives plus false negative. And next, let us see precision and recall. Yes. Everything we will be calculating from this confusion matrix only, everywhere. See, you just need to remember the formulas, nothing more than the content. The precision is the formula having true positives divided by true positives plus false positives. PP is nothing but true positives, FP is nothing but false positives. TN is nothing but true negatives, and FM is nothing but false negatives. This is the formula for true positives, and below is the formula for recall. And F1 score is the combination of 2 into precision into recall divided by precision plus recall. And accuracy is the formula of total, everything. See, this is the confusion matrix. From this confusion matrix, we are able to predict precision, recall, F1 score, and accuracy. Everything we will be calculating from this confusion matrix only. In some images, the actuals may be presenting on above, that is horizontally, and in some images it may be representing actual values like this. So anything is fine only, nothing to worry. Okay, so these are all the things we need to check. Normally F1 score we will be measuring as the final thing from the confusion matrix. From the confusion matrix seeing itself, we can tell. So true positives and true negatives should be high, and these false negatives should be 0, and these false positives also should be 0. Why? Because, for example, one person came for the treatment. He attended a test of cancer test. Actually, he is not having cancer. But whenever the tests came, whenever the reports came, my model predicted that as this person is having cancer. That is a problem, right? Actually, in the reality, he is not having cancer, but my model predicted that as having cancer. That is the problem. Same scenario, if you take it in the reverse order, the person is having cancer, but my model predicted that as not cancer. That is also another problem. In the first scenario, even though he is not having cancer, we started treatment for him. Why unnecessarily we need to give the treatment, even though if he is not having cancer? That is also a problem. In the second scenario, he is having cancer, but our ML model predicted that as not having cancer. We didn't do any treatment. That is also another problem. So like this, we need to concentrate on false negatives and false positives both. That's why you should be in the situation to reduce these false negatives and false positives into 0. To make it happen, we should, in the confusion matrix, most probably we should get very limited to very nearby zeros. It's not in the tens or hundreds also. It should be 1, 2, something else like that. Okay. So this is the thing related to this classification algorithms and classification metrics. So remaining algorithms we will discuss. So that is not a big deal. So first of all, we need to do one project on the classification. So here the problem statement is that it is one of the project related to banking domain. In our previous project, we have discussed retail domain. In the clustering, we have discussed project related to insurance domain. That is, insurance persons should be clustered. In the previous project, we have discussed about sales project. That is retail domain. Now, in the classification, we are going to discuss about this what I can say, banking domain. So here the problem statement is the company is having some credit card defaulters. Credit card defaulters is nothing but some of them are not paying. Some of them are not paying. So by using the machine learning model, we need to predict whether the person is credit card defaulter or not. So normally banking, they won't provide all the details directly. So that's why we are getting some features not given in the proper format. You can ignore the feature names. These are all the data related to default. So here the default feature is C, default payment next month. For example, if the person is not doing payment for previous 4 months, 3 months, this month, like that, he may not do for next month. What the company will do, what the bank will do, if the model predicted that as this person is going to be defaulter, immediately that will go to his home and they will check his personal things, all those things, and they will try to recover the credit card default amount. That is how these ML models are using in the banking domain. So normally to collect the data from the databases, we will be using the host address. See, this MySQL is one of the library which we will be using to connect to the MySQL library. And this local host, normally in the real time, you will be getting host address. In the place of local host, you will be getting addresses like 192.11, 12.8.5, something like that you will be getting host address. And user, you will be getting usernames like root, admin, something else. And the password, you will be getting passwords also. These are all the credentials will be provided by the DB engineers, don't worry. In the real time, we can check with the database credentials and they will provide you. And the plugin we need to provide, and the database name also they will be providing, which database the data is having. So normally at that time, in the previous batch, we have created one local host, that is we are able to install the MySQL server in my local laptop. We are able to create the user, password and database name, and we are able to push the data to the database. So normally if you see the SQL sessions, we will be able to install the SQL servers also. Once I am able to connect to the database, don't execute this code. This code won't work in your laptop. Why? Because these credentials are outdated. These are just for your explanation purpose only. I have added this lines of code, not for execution purpose. For execution purpose, from where you can start reading from the CSV file. You can do it. You need to read the CSV file and you need to do it. See, from here you can start. This data.csv, you will be having data frame name called default of credit card declines. This CSV file name you can use and you can start executing the code. So here, multiple steps I have applied. Just go through each and every line of code. I did some basic EDA and try to do filling null values, finding the null values, and scatter plotting and box plotting. And after that, I was able to find out some outliers. See, all these are outliers. These are outliers. I was able to find out outliers, and I was able to do the histograms, and I was able to divide my data into X and Y, and able to build the logistic regression algorithm and check it from your end. So just check the accuracy, how your model is performing. So just tell me after that whether the model is overfitting or underfitting. After that, I check the correlation matrix. What you need to do, you just need to check each and every line of code, each and every cell of code, what I have written, what I'm doing here, what you can improve, what are the steps you can try to improve the accuracy. If I apply standardization, is there any accuracy improvement will happen? So these are all the feature importance, which I did it. So you just try it from your end, try to explore it from the Google, all those things. See, here I applied standardization, standard scalar, capital S and capital S, both we need to provide. So once if I applied standardization, is there any accuracy changing? We need to check all those things. See, before standardization, the accuracy is around 70%. Now after standardization, the accuracy got increased. You need to check all those things. Just check this classification project also. Just come up with your questions. Okay. This is how we need to practice. So you guys are very slow in completing the projects. Just make it fast. Just try to complete as early as possible. So already this code is available in the drive, and I will be uploading this recording session. Just go through each and every cell, try to execute the code and try to understand the code, what we are trying to do over there. Then only you can understand on your own. It will easy for you to explain during the interview also. So clear everyone? So I'm expecting each and everyone should complete it by today. Let us see how many of guys will complete it by today. Okay, guys.